Yeah, I did forget to tell the QCon people that my affiliation had changed since the last time I spoke here, so I'm listed under my old employer in the program. But that's fair, I suppose, because it was while I was working at Relevance that I was introduced to Clojure and got my experience with it for the most part before I moved to InfoEther in the middle of last year. One of the founders of Relevance, my old company, is Stuart Halloway, who wrote the Clojure programming book that's published by the Pragmatic Programmers. And it was, I think, the first Clojure programming book, and he's now one of the Clojure core team members working on the core libraries and things like that. So he and I working together taught me a lot about Clojure and got to use it on some really interesting projects. Including a couple of web applications. I was hoping that speaking this late in the day, I would not have, in a track about the functional web, I would not have to spend much time convincing you of why functional languages are a good fit for web application development. And I know not everybody has sat in this room all day listening to all the talks, but sure enough, Greg, the very first talk of the day, went over that in a lot of respects about why functional programming languages are a good fit for web application development. And I'm not going to spend a lot of time discussing that, except just to note, the way HTTP works, you get a big blob of text in, and you operate on that and produce a completely new big blob of text out the other end. And just from right there, you can see it's a natural fit for modeling as function application. And it turns out that functional languages are really good at modularizing the various different kinds of responsibilities that have to take place for a typical web application. And the frameworks that are evolving and growing in all of the popular functional languages today are really impressive and coming along nicely in a very short period of time. I am going to spend a little bit of time introducing you to Clojure. Clojure is a new functional language that's already quite popular. It's a modern dialect of Lisp. Complete with all the parentheses and dynamically typed language, all that stuff. It runs on the JVM, which is a selling point to a lot of people. It actually is not a selling point to me. I jumped to being a full-time Ruby programmer about 5 years ago from having done a lot of Java work and made the hard choice to leave the JVM behind. And once I did, I didn't really miss it all that much. But that's not one of the reasons I like Clojure. I like it because it's a wonderful language and it's pleasant to use and feels good as you program in it. I find it easy to solve problems with. But to a lot of people, the fact that it runs on the JVM is a big help. And once in a while, I have, in using it, found opportunities to use some of the Java libraries and frameworks from Clojure to help solve problems, and that was handy. Clojure's design priorities are performance and scalable concurrency. Clojure incorporates a lot of interesting ideas from academia that, prior to Rich Hickey implementing them in Clojure, hadn't seen a lot of mainstream exposure at all in order to achieve really good performance on the JVM in spite of being a somewhat different language from that the JVM was designed for. It has really interesting concurrency features and models. They're based on the JVM's native threads. Clojure doesn't roll its own core concurrency primitives, but it has built very nice abstractions on top of those, exploiting the functional nature of the language and a few other things. And we'll see some of that. On the surface, It's a Lisp with some modern touches. So if you have any familiarity with Lisp, lots of things will look very familiar. It won't be hard for you to come up to speed. If you have a lot of familiarity with Lisp, if you're an old Lisp programmer with a lot of background there, some parts of Clojure will probably annoy you because it does break with tradition in a few places. It is not. It's a modern Lisp, but he's made some different choices. There are some extra literals for things like maps, vectors, sets, and regexps, and I'll talk a bit about those in a little bit more. It has built-in support for metadata on variables and functions and a few other constructs. More than just doc strings, general metadata. Hickey took the opportunity to rename some of the traditional obscure cryptic Lisp functions. It was funny to watch this happen. I've not been in the core of the Lisp community ever, really, but I've watched it for years and years, and I've noticed how every time anybody implemented a new Lisp, which happens about every couple of weeks, or did for a while, as long as they stuck close to car and cdr and didn't mess with any of the traditional names, people thought it was great. And if they tried to update that so that it, the language, the core of the language didn't actually reflect the hardware architecture of the first machine Lisp was ever implemented on back in the 50s, people kind of got upset. No, that's not, it's car and cdr. It's not first and rest or first and tail or anything like that. And Rich seems to have gotten away with it, which is neat. He updated some of those names and simplified their semantics. There's only one version of let now, for example. And for the most part, the old traditional Lisp people haven't been screaming at him very much, which I think is nice. Introduces the concept of sequences, which is a generalization of the old Lisp list model. And sequences incorporate vectors and sets, well, not sets, but vectors, and there's a true Lisp list. There are vectors, and there are a few other representations of sequences. And that turns out to be very important for having efficient concurrent data structures in the language. And there's good support for destructuring in assignments and function parameters. Underneath the covers, the most interesting part of Clojure to me is the concurrent data structures. Unlike traditional Lisps, which allowed you to write functional programs, but also allowed you to write procedural programs or basically anything else you wanted to do, Clojure really tries to encourage you to write functional programs using pure functions and immutable data. It doesn't take a really hard line on that. There are a lot of loopholes, but it makes those loopholes painful. It really is designed so that the path of least resistance in Clojure is to write pure functions with immutable data and write in a functional style. That works really well. One of the keys to that is the nifty concurrent data structures. If you're not allowed to ever mutate a hash or an array or a vector or any of those things, every time you want to add something to a hash, you have to create a new one that's a copy of the old one and then add the new stuff to it. That could potentially be very slow, but Rich Hickey implemented some very sophisticated concurrent data structures that make duplication and incremental changes very cheap. The new version of the hash, both in terms of speed and in terms of memory. If you have a hash of 150 elements and you duplicate it and create and then add one more element to it, it will share almost all of the memory used by the first hash. But from the Clojure level will appear to be an entirely different object with entirely different state. It incorporates a couple of concurrency facilities at a higher level than raw Java threads. A shared transactional memory model where multiple threads have access to the same objects, well, not to the same objects, to the same vars, and can change their values, but only within the scope of a transaction. So that there's transaction rollback facilities, and the intermediate states can be hidden from other users. There's a concept of agents, which I was describing to somebody yesterday, I think Justin and Creston, about how, in my mind, agents are sort of a dual of Erlang's processes. If you're familiar with Erlang, an Erlang process is a function that runs and you send data to it and receive data back. An agent in Clojure is the inverse of that. It's a piece of data, an encapsulated piece of state. Usually a hash, but it doesn't have to be. And you dispatch functions to it, and those functions run on a different thread and receive that data as input and return the new value to be stored as that data. So it's kind of a new thing. I'm not familiar with it in any other language. It's interesting to think it's the inverse of Erlang's processes, but in my experience with it, can be used in a very similar way for purposes of design. There are atoms and dynamic vars, dynamically scoped variables, which would be used like a thread local variable in Java or Ruby. And as we heard in the first talk this morning about Haskell, Clojure is lazily evaluated in most places by default. It's not as pure and rigorous about that as Haskell is, but most of the potentially expensive operations on sequences are defined to be lazy. So it only evaluates enough of the expression as it needs to at any given time and waits until it's asked to evaluate the next element of a sequence or list or something like that. And that does take a bit of getting used to. There will be times when you simply can't figure out why it's hard to debug a particular situation because you've forgotten that, oh, this hasn't all been evaluated yet at the time I'm trying to inspect it. Running on the JVM, like nearly all other languages that run on the JVM, Clojure incorporates Java integration. And I've seen languages that were implemented on the JVM where their integration with Java is a bit strained. I think this is one of the really sweet spots of Clojure. Integration with Java is wonderful and easy. Java methods appear more or less like single dispatch generic functions. And the syntax looks like this. So if you have a properties object where in Java you would say props.size, here it's the function .size, and the first parameter is the object props. And if you want to add a new one, .put props, key and value. And there are several macros for making sort of typical Java-style operations handy and convenient. And one of them is the do-to macro, which I really like. It's fairly typical of Java APIs that you create an object and then you have to call a bunch of methods on it to configure that object. And do-to makes that very easy. Do-to some object and then a series of method calls on that object. It's not restricted to Java. It's really do-to some value and call a series of functions on that value. But what it's really, where it's really handy is for creating the class name with the dot after the end used as a function is a shorthand for the constructor, shorthand for .new. Creating a new object and then configuring it by immediately calling a few other methods, and then the entire do-to macro returns the object itself, not the result of the last method call. I would rather write Java code in Clojure after having had a few weeks of exposure to Clojure. I had reached the conclusion that it was way more convenient to write Java in Clojure than it was in Java. The philosophy of Clojure is to be pragmatic rather than purist. As I mentioned, there are loopholes in the sort of pure functional side of Clojure, and you can have variables that you modify, and that's actually inevitable if you want to have good interoperation with Java. But in almost all cases, I've found that it's easier to go with the flow and do things the Clojure way and write pure functions with immutable data, and that makes testing and debugging a lot easier and has a lot of other advantages and allows both Clojure and the JVM to do useful optimizations for you. Starting about 10 years ago, it became a pattern that whenever anybody introduced a new programming language, the first thing that would happen was that a bunch of groups would go off and write competing unit testing frameworks for that language, within days. Now it seems that still happens, but now it seems that also people will go off and write competing web frameworks for any new language that appears. There are a lot of web frameworks of various sizes and shapes and scales that are targeted at Clojure. My friend Howard Lewis Shipp, who wrote the Tapestry framework for Java, wrote Cascade, and as Justin mentioned in his talk, Clothesline is a Clojure port of WebMachine. Composure was really the first one to get any buzz, and that's kind of it's devolved. Composure started out as more or less a full stack framework inspired by the Rails way of doing things, but it's gradually been sort of pulled apart and different pieces of it calved off into their own little modules, and now Composure is really just a thin layer on top of Ring. Conjure and Twister and WebJure and these other things. The jure suffix seems to be the fad, just like the G prefix was with all the GNU tools, and J with everything Java, and but we're already getting tired of that. I'm going to talk today about Ring, which is a delightful little, and I was calling it a framework, but Justin, made the point that WebMachine isn't a framework, and it got me started thinking Ring's not really a framework either. It's a little shim and a way of building web applications and some utilities and built-in handlers, but it's not really a full framework. It's just a little library that helps you build web applications, which is nice. There are also several competing HTML generation libraries, and I haven't heard many people talk about this aspect of web development today in this track, and this is particularly near and dear to my heart because it has been brought to my attention in a painful way that how you choose to generate HTML really matters, even in a functional language, and you should make wise choices about that, so I'm going to talk about that too. There are plenty of options for persistence and all the other things you need to do to build web applications, but those things are so generally useful. I don't consider them necessarily a part of web development, so I'm not going to cover them in particular. Some of these libraries are native Clojure libraries, but as I mentioned, you can always use all of the Java libraries that are there as well. So let's talk about Ring. The architecture of Ring is that in your web application you have your app that really knows how to do the things that are specific to your problem domain, and then a bunch of handlers, and a request comes in, And that request is filtered down through all the handlers, and then the app gets to take care of it and produce a response. And the response gets filtered back through all the handlers, and then is finally converted at the last minute into a full HTTP response and sent back out to the web browser. You may, depending on your background, you may recognize this as being similar to Python's WSGI or Ruby's rack. And in fact, Ring was supposedly inspired by those in some way. And being a Rails person, Rack was kind of late to the game, and Rack is a Ruby framework that helps you link to web servers and do similar kinds of things. And Rack didn't come along until Rails 2 point something or another. And but every iteration of Rails, more and more things are removed from the Rails framework proper and pushed off into handlers, effectively, to be done in a more reusable way that's not specific to Rails, but can be used with any of the other Ruby web frameworks that work on top of Rack. And the same thing is true here, that the style of web development, an amazing number of things can be encapsulated in little reusable handlers, or sometimes very specific handlers for your own application, but many of them are reusable. Each of those handlers has the option of changing the incoming request, augmenting it, filtering it, transforming parts of it, any kind of change that it wants to make while it is en route to the actual application code. And then once the response is generated, likewise, they all have the opportunity to change the response and add their 2 cents to the argument before it gets sent back out to the web browser. A handler can also choose to short-circuit the whole process and just generate its own response and not let any of the subsequent parts have their say. You've probably already figured out that these handlers are nothing more than one function calling another. And that's the way this is implemented. It's a series of nested function calls. This handler is called with the request object as its parameter. It gets to do whatever it wants to do before everything else is called, and then it calls the next handler with the request, possibly changed, as its parameter, gets the response as the return value, and possibly changes it before returning it itself. The app part of this diagram made me promise that I would point out that it is really nothing but a handler as well. So Ring is a very simple architecture where you have handlers that take one parameter and have one that's the request. They know about the next handler, except in the last case where there is no handler and it has to do all the rest of it by itself. And they build and return the response or filter the response through. Simple. What does the request look like? Well, the request is a Clojure map, which is actually, it implements the java.util.map interface, but it's one of these Clojure concurrent data structures, immutable concurrent data structures that I mentioned. And it has a number of keys and a number of values, which tells you basically everything there is to know about the incoming request. The little shim at the front of Ring before the first handler gets called has the job of parsing the HTTP headers and body apart and putting them into this map format. So you know the port and the server name for virtual host purposes, address of the remote system, URI, the query string, the scheme, on down the row here, headers. If it is a request with a body, the body element in this map will be an input stream. That's a Java input stream, which can be read to gather the body and do with as you will. And also content type and content length may be set. And at some point, you'll want to generate a response. And the response is also a map with a status, a map of headers, and a body. And that body can either be a literal string, as it is here, a sequence which will be joined and converted into strings, a file from which the body will be read, or an input stream. Nothing magic, very low tech, actually. Just gives you access to the guts of what's going on. You have a question?
What about repeatable reads from the input stream? So if the first vendor reads from the input stream, and the second wants to do that as well, is that somewhere?
I don't know. I've never had need to do that. I mean, I don't know whether that's a buffered input stream or anything like that. One thing, because you can modify the request, you could always read the input stream and then replace it with a string input stream or something like that. An app looks like this. It's a function. It takes the request as its parameter and returns a response. So this is a very simple app that always just produces the same thing no matter what URL you go to within that web application. In this case, we're building the response directly. Here's a slightly more sensible app where we check to see if the URI in the request is something we're looking for, and if so, we return that. Otherwise, we return a not found response. And this is just like the last slide where we build the response directly as a map, but Ring also includes some little helper functions, utility functions for building responses in a little bit cleaner way. So you could do this same thing in this form, and this is the way you more usually see it. Build a response with this body and a default 200 status code and no headers, and then add to that a content type and a status. This arrow here is a Clojure macro that threads these together, which is not the kind of thing you would have seen in a traditional list because it wouldn't have been too useful. But in Clojure, where you're not allowed to modify any of these data structures in place, you have to always take one as input and return a new one as output. Threading these functions together, composing them in this way is very useful. So what this will really expand to is status of content type of response. And the final thing that it's called is status. It gets its chance to add the 404 to the response before it's eventually returned. While I'm here, I'll take the opportunity to point out something about Clojure that'll be confusing if you see it for the first time without knowing what it means. This function call here, URI of the request. URI is a Clojure keyword. It's a variant of a symbol, really. And Clojure, how many of you have list backgrounds? So I can see whether it's worth it to really explain this. Okay, enough that I should explain it this way. Clojure has follows the common Lisp model of function binding rather than the scheme model. So a variable has both a value and a function binding. So this symbol is, or this keyword is just a keyword, but when used in this context as a function, its function body gets invoked. And the semantics of a keyword when used as a function is look myself up in this collection using myself as the key. So this is essentially request.get URI. Interestingly enough, collections also have function bodies, so they can be used as functions. Note the change between these two slides. If you put the request first, it has exactly the same effect. The semantics of a Clojure collection, when used as a function, is, oh, take my parameter and look that up as a key in myself. Sometimes it just really seems like the right thing to do it one way, and sometimes it just really seems like the right thing to do it the other way, and sometimes it doesn't matter. I would probably actually write it in this case, but it does turn out to be really handy to be able to specify it in either direction, because depending on what you're doing, one seems more natural than the other, and you quickly get used to seeing that and understanding what it means. So that's an app. The app, sits at the end of the chain, and it doesn't call any other handlers. It just, it might call other methods to help or whatever, but it eventually just generates the response on its own. A handler, one of those handlers, which are sometimes called middleware, although technically that's not quite right for a reason I'll show you. The middleware handlers are structurally the same. It's a function that takes a request as a parameter and returns a response. But it also knows about the next handler in the chain. So it does what it wants to do and then calls the next handler and returns that handler's, the response that comes back from that handler. In this case, it optionally will short-circuit that. If the authorized function says nuh-uh, then instead of calling the handler, it will generate an access denied response and return that directly, and then the rest of the chain never gets invoked. Make sense? The reason that there's a little technicality about handlers versus middleware. Think about how you would string a bunch of these together so that they each know about the next handler down the chain. It turns out that you need, or at least it's convenient to have, a helper function for that purpose. And those helper functions are what Ring properly calls middleware. So a true handler like that would be written this way. Instead of a named auth function, you would have a wrap auth function that took the next handler as its argument, and it returns the handler function, which knows about the handler because of Clojure semantics. It's a higher order function that generates as its return value a new function that's going to be used as the handler. And then the way you string them all together, this is really a full-fledged Ring app. You build your application that handles the final part of the request, and then you define app as the composition of this handler, wrap auth, wrap log, where you want to log the body, wrap params. These are all middleware. And it builds a string of 3 handlers and finally the app at the end. So the request here, it's typical to see something like this in the initialization of a Ring application. And the way you read this is that the request comes in this way and gets turned around and the response goes out that way. Let's go back and look at that request. You'll notice that the query string parameter hasn't been parsed. And if there were multiple parameters in that query string, there would be the ampersands there. It's all just one big string. So the way to deal with that is to go add to this chain. I went back too far. Add to this chain wrap params. The Params middleware parses that query string, and it adds 3 new keys to the request. It parses the query string, and if there's a body that is, one of the types of bodies that indicates these are form parameters, it'll parse that body as well. So it adds 3 new keys to the request. Query params, which it gets out of the query string. In this case, search. The search parameter has a value of ring. Form params, which it parses out of the body, either a multi-part form request or a URL encoded form body. And params, which is a merge of these two. So you see all your params in one place. As soon as you add wrap params to your middleware chain, all of a sudden now everything else above that on the chain gets to see the parsed parameters. It's amazing how many things that you need to do in web applications can be represented quite nicely as little middlewares. These are the standard ones that come in the Ring library. Yes, question?
Matter in the order.
Yes, it matters the order, and I'll get to that in a minute, okay? It does matter because it's just a set of nested functions. So if you have something that's going to inspect these values, it has to get control after wrap params. And that's one reason why back here, wrap params is very first. It wouldn't always be first, but it needs to be before auth, probably, because auth is, you're probably, you might be submitting a login form or something like that, and you want to see those parameters. Good question. So these are the standard middlewares that come with the Ring library. File, you tell it a directory, and any request that comes in, it checks to see if the URL matches the path of a file in that directory or subdirectories, and if so, it just returns right away and serves that file up. So it's a static file server. Static is a slightly more advanced form of file. You, in addition to giving it a directory to serve static files from, you give it a set of patterns for what file names you want it to serve. And rather than doing a lot of disk I/O, checking every request to see if it matches a file that exists there, it first checks the path against the parameter to see if there's a reasonable, if I would even be allowed to serve this file, and only then would it go do the disk I/O to see if the file was really there. So it's a little more efficient for those kinds of things. Content type tries to guess from any dot suffix on the end of the URL path what the content type of the response might be and plugs it in for you. So .html or .gif or JPEG or PNG or something like that. File info should be should come before file or static. And if the response, you remember when I showed you the response, I said that the body could be a string or an input stream or a Java file object. If the input, and a Java file object is what file and static will set the body to. If the response body is a file object, file info goes and inspects that file, or not the contents of the file, but does a stat on it in the file system, and supplies the content type if it can, and a last modified header, and a content length, and things like that. And if the request has an if modified since header in it, it will look at the last modified date of the file in question and avoid, remove the file itself from the response if it hasn't been modified. So on and on. Cookies parses the cookies header and adds a new hash to the request containing all the cookies. Session uses one of those cookies to figure out which session is being used, or create a new one if it's the first request in a session. And the session can either store the session data. The session middleware can store the session data either in the cookie or in memory. Flash implements a concept that I think originated in Rails, if you have any Rails experience, of a little place, special place in the session where you store a value that's going to be needed by the next request. That's particularly useful when you have just done some destructive action and you want to redirect rather than displaying a response, but you have some message or something you want to put in on the page that gets shown after the redirect. So Flash is handy for that. Params, we've seen various different enhancements of params, so you can get the keys as keywords instead of strings, or parse multi-part form submissions for file uploads. Nested params, which does kind of a Rails-like parameter syntax where you can specify nested hashes of params. And 3 development tasks, development middlewares. Lint, which checks to see if your response is well formed and has any extraneous stuff in there that Ring won't be able to deal with. Reload, which makes sure your source files get reloaded on every request. And stack trace, which catches exceptions and gives you a nice stack trace. There are a lot of third-party things as well. Won't go into all of those except to say you can also add some third-party session stores that store your sessions in Mongo or Redis or Riak. Upload progress is a neat one. If your multi-part form params include a file upload, that middleware goes ahead and dispatches so the file upload can be handled, but it provides a response that gives you an upload progress bar. I haven't looked into it to see how it does that, but it's really neat. Ring also includes adapters to hook it into various different web servers, and it comes with Apache and Jetty adapters, and it comes with a bundled Jetty so you can run your apps out of the box under Jetty and develop them, and there are other adapters available from the community. It doesn't really include any support for routing. For simple apps, you can just build a little routing table with regex or strings to match URLs and handler functions to handle those particular URLs. And then as you get more sophisticated, evolve that into something different. Or there are several different libraries right now, and Clojure is one of them. I mentioned it started out as a full-fledged web framework. And now it's really just kind of a little set of macros to help you build routes on top of Ring. Processing the requests at the end of the line in the app looks kind of like this. We've seen stuff like this before, but I like to kind of conceptually keep things organized as go and do all the stuff you need to do first, and then build the response. So my handlers nearly always start with a let that includes function calls to go and do the work, gather the data, change things in the database, whatever, set variables that are going to be used to build the response, and then at the end build the response, render a template or something. So it's kind of organized that way of do all the work and then build the response. If there are things that you may want to include in the response, depending on the values of other things, but you may not, it seems kind of wasteful to go and prepare all that data here anyway when you don't know if it's actually going to be used in the response. But why don't we care? Lazy evaluation. And in fact, functional languages make it easy to do. They don't necessarily give you, but they make it easy to do all kinds of things that help with that problem. Memoization and lazy evaluated functions and things like that. So in terms of the source code, it would be laid out like, go do all the work and then build the response. But it may, in fact, be the case that the work doesn't get done until these values are actually referenced from a template. Now, you do have to be kind of smart about how you do the work and what your return values are, but it's fairly easy to get around those issues if you have them. In this case, we're rendering an error template here in some cases. It's usually handy to handle errors in one place in a common way related to your application. The way I would do this is instead of rendering a template when the login failed, if there's no user found that's valid with that user ID and password, call some error function which would raise an exception. Sorry, I'm using Ruby terminology. Would throw an exception. Clojure, being based on Java, has full access to Java's exception handling mechanisms, although it hides all that nasty checked exception stuff from you. And so you can throw an exception here, which would be done down in the error function. And then write your own little middleware that sits ahead of your app on the chain that would catch those exceptions, because the middleware has to call the next handler, so it can do that within a try macro. And it can catch that exception and generate canned responses for particular kinds of errors. And this is another place where the ordering of the middleware is important. If you're going to be throwing exceptions that are going to be caught by a piece of middleware, then everything between the app and that piece of middleware is going to get bypassed by the exception unwinding the stack before it gets to the one that catches the exception. So if you have error handling middleware, you want that to be pretty close to your app so that other things you want to happen, like making sure the session cookie gets updated on the way out in the response and things like that, don't get bypassed when there are error responses. Or who knows, maybe there will be cases where you do want a particular thing to not happen in the case of an error response. So you just put it below the error handler. I want to, before I finish, talk a little bit about templating. When I did my first web app in Clojure, we did it using Composure, which was the most mature web framework back then. It was fairly early on. Composure comes with its own HTML generation library called CLJ HTML. At least it doesn't end with jure, right? And CLJ HTML is a builder-style library that lets you represent HTML structure as Lisp code, or in this case, Lisp data structures. And then that gets traversed. So you have spans and anchor tags and href attributes and things. And this gets traversed and turned into HTML after this code runs. And so this is a little helper method we wrote for a login box. And if there's a user, if a user is logged in, then we build, welcome user and give you a logout link. If the user is not logged in, we have some login text here, and we say, give them a sign-in link. And then the render method, render function, takes a body, renders the layout of the HTML page, and calls login box to put the login at a particular position on every page. Simple enough. And I think every web framework should include a library like this for programmatically building HTML. However, sometimes it's nice to have templates. And we were in a hurry, and we thought we need to go find a templating library to use, and this was very early in the days of Clojure, and we didn't know of any Clojure-specific templating libraries, so we looked for Java templating libraries. How many of you are familiar with string template? Okay. String template sounded like a really good fit. It's fairly strict. It doesn't allow you to put much logic. You can only do very simple kinds of tests on attribute, whether an attribute is present or absent in the thing. And so it helps keep logic out of your views. And it's designed on functional principles. Template operations in string template are modeled as function application. Awesome. We're all on this functional programming thing now, so it's a good fit. When you render a string template, you can pass in either a Java object with methods and the whole 9 yards, or a map. Well, we're in Clojure. We're not being object-oriented about this, and Clojure does these map things really well, so let's build maps. String template is based on the premise that you don't have logic in your views. You keep logic out of the presentation layer. And that really works well when it's used as a Java templating library because there's this big loophole. String template allows you to get properties from an object and put them in there. But the property of that object might actually be a method that includes a lot of logic in it to do interesting things that you need to do. So as far as string template is concerned, I'm just calling a getter or calling a method on the object and getting the value back, but all kinds of stuff might be happening before that in there. We were passing in maps, and we found that it was impossible to do even trivial things that are really presentation-oriented, like optionally pluralizing a word in a message based on the count of things you're talking about. It turns out, in my view, string template is based on the wrong premise. You don't want to eliminate logic from your presentation layer. You want to only have presentation logic in your presentation layer. And you want to make it easy to keep that well-factored, just as well-factored as all the other parts of your code. And so string template turned out to not be a very good fit. Oh, I had one more slide about the CLJ HTML thing. With that in place, with those little functions for render and index, or render and login box, we defined an index function that took the request and rendered a response using that. So string template turned out not to be the thing. And there are two templating libraries for Clojure that I think are really good and are really appropriate for use in a functional language. And one of them tries to take a very pure functional style. Both of them are, in some sense, purely functional. But one of them tries to take a very purist approach in a similar way to the way string template does. And one of them tries to take a very pragmatic sort of JSP embedded code kind of approach. And they both have their value. I actually like the more pragmatic one. I'll start out with the purest one, enlive. The idea of enlive is very much like XSLT, I guess, except it only uses angle brackets where they're important and uses curly brackets or parentheses everywhere else. You have templates that are in their own files, and they are HTML, and they are only HTML. So this is the index that has all the layout stuff, and you tell enlive, I want to define a template called index, and the template's in this file, and you'll take a parameter that's body text, and then you have a set of transformation functions, right? It's a set of, the transformation function here defined in this template function is multiple pairs of patterns and actions. And the patterns are a sort of Clojure-ish representation of CSS selector syntax. So when we render this template, we want to find the div of class container, and we want to prepend the string we get from calling login box right before the container. And then we want to find the div with ID of content, and we want to replace its content with the body text that was passed in. Okay? And so if we go back to the template, here's the container, and we'll stick the login box up here, and here's the content, and we take this body text, which would display when a designer's working with this page and playing with it and everything. We completely eliminate that and replace it with whatever was passed in. And for smaller things, we could have a file full of snippets or multiple files full of snippets. And in our file of snippets, we would have the login box snippet with an ID. And in Live lets us define a snippet function, login box. This snippet will be found in that HTML file, and it will be found with the ID login. So you can have multiple snippets all there in the same file. So you don't have multiple little tiny files for 2 or 3 line snippets of HTML. Takes no parameters. You find the div called with the ID of login, and within it the span with class login text. And Live has its own programmatic HTML generation library. Say replace the content with an HTML snippet, which is, if logged in, give a sign out link, and otherwise give a sign in link, same as before. Because we call def template, this is a function name. Def template defines a function for us with this name. So to render that template, we just call index with our body text, and it returns the rendered text, or more accurately, I think, returns a function which, when evaluated lazily, will generate the text for us. Make sense? It's really nice. It's really nice if you want to try to keep all logic out of your HTML files. It has the disadvantage, because it uses CSS selector syntax, that it can only be used on XML files. And, I guess it's because I'm old or something. I'm not all that excited about the relentless purity. I'm pretty good at knowing not to go wild with putting too much logic into my views. So I don't necessarily feel compelled to try to keep those things separate. The other templating library is called Fleet. This is the one that takes a more pragmatic approach, and it can be used with files that are not HTML or not XML. Here is a template in Fleet, and you can see that it takes the JSP or ERB style approach of having embedded code. And so that it still looks Lispy, the delimiters are angle bracket parenthesis, and it will evaluate that as an expression, as a Lisp function, call the stir function to convert the value to a string, and embed that in this place as it's evaluating the template. And likewise, this one, take data, which is the name of data that was passed into this template, and convert it to a string and plug it in as the content. Similarly, you would have a template for the login box, and the designer of Fleet had an interesting challenge. With a templating library like this, you have to have a delimiter that lets you say, okay, here's my code, but then sometimes you want to have more template-y stuff in the middle of the code. And so if a string begins with the angle bracket and ends with an angle bracket, this is treated as more template code to be evaluated. And actually right there, it looks kind of cumbersome. The way it's meant to be written is like this. forgot to do that reformatting. I'm used to it enough that it doesn't really bother me to have it that way, but this is the way it's meant to be written. Oh, I'm sorry, that wasn't even up on the screen. So, so you start the string, close the angle bracket there, and then new line, and have your template-y stuff on lines all by themselves, and then open the angle bracket again right before the end of the string. It's a bit funky. You get used to it quickly, and it's really nice. And it preserves the sort of spaceshipy look of the embedded code portions. And that's why the library is called Fleet, actually, because they look like little spaceships, little flying saucers. And in fact, in a project where you're building complicated layouts and everything, you look at this, and as soon as somebody tells you, doesn't that look like a kind of a flying saucer? All of a sudden, your template looks like a fleet of flying saucers. I mentioned that it's very important for a templating system to make it easy to factor your view code well, your presentation code well. And with live, you're just defining functions. You use def template instead of defn and def snippet, but you're defining functions. And so you use Clojure's namespace support and put them in whatever function you want, or whatever namespace you want. And it makes it really easy to keep things factored and in the right place. Fleet generates functions for you from these template files. But the designer of Fleet understood this need, and when you the way you tell it to look in this directory and take all these files and generate rendering functions from them is you call fleetNS. FleetNS takes first a namespace and then the name of the directory to go look in for template files. And all of the functions it generates, it puts in that namespace. How many of you have worked with Clojure at all? Okay, good. Nice. I encourage you to try it out. It's if you've been working with Scala, which to me is too big of a language and complicated, Clojure is refreshingly simple. And also, you know, the dynamic typing is different. The first speaker of the day spoke about Haskell and talked about how important he thinks static types are. And I completely respect that view. But I really like working in a language like Clojure that's dynamically typed. And that's a lot of fun as well. Ring is easy to get started with. Brian Merrick is writing a book on Ring for the Pragmatic Press. And he's got drafts of the first couple of chapters online, and I have to recommend that you go read his book because having read the first couple of chapters in draft form, I found it impossible to approach teaching Ring in this talk in any other way. So I have to credit him with some of the order in which I presented the material. I think I've run just slightly over time, but thanks.